Good morning, everyone. Today we will learn about propositions. Before we dive into the lesson, let's review some related vocabulary and key terms together so that we can follow the lecture more effectively. Okay? 1. Proposition. Proposition. 2. True proposition. True proposition. 3. False proposition. False proposition. 4. Proposition with variables. Proposition with variables. 5. Negation of a proposition. Negation of a proposition. 6. Conditional proposition. Conditional proposition. 7. Converse proposition. Converse proposition. 8. Equivalent propositions. Equivalent propositions. 9. Necessary and sufficient condition. Necessary and sufficient condition. 10. Mathematical symbols. Mathematical symbols. Foron. Exist. 11. Variable. 12. Assertion. 13. Truth value. 14. Mathematical logic. 15. Theorem. Today, we will explore 3 important concepts in detail. Propositions with variables, and negation of propositions. To begin, who can define a proposition? Yeah, Emerald.
A proposition is a statement that can be clearly identified as either true or false, but it cannot be both true and false at the same time.
Very good, Emerald. Can you provide an example?
For example, France won the 2018 World Cup. This is a true proposition.
Can you provide an example? Excellent. Sophia, can you give me another example of a proposition?
16 is not a prime number. This is also a proposition, and it is true because 16 is a perfect square.
Excellent, Sophia. Now, let's move on to the proposition with variables. Floret, can you explain this concept?
A proposition with variables is a statement that includes variables. It only becomes a true or false proposition when the variables are assigned specific values. For example, 8 is divisible by 5 is a proposition with variables.
That's correct, Floret. Can you elaborate? For instance, is that proposition true when n equal to 10?
A proposition with variables is a statement that includes variables. It only becomes a true or false proposition when the variables are assigned specific values. For example, n is divisible by 5 is a proposition with variables. Yes, it's true, because 10 is divisible by 5.
Well done. How about when n equal to 7?
When n equals 7, the proposition is false because 7 is not divisible by 5.
Exactly. Imagine each proposition with variables has an open-ended question. When you substitute a value for the variable, the question gets the clear answer, true or false. This approach helps you to grasp its nature better. Now, let's move to the final part, negation of the proposition. Kianai, do you know what the negation of the proposition is?
The negation of a proposition is another proposition with the opposite truth value. If the original proposition is true, its negation is false and vice versa.
That's absolutely correct, Kianai. Can you give an example?
For instance, the proposition 6 is not a prime number. Its negation would be 6 is a prime number. Since the original proposition is true, its negation is false.
Excellent, Labis. Can you try another example?
Sure. The proposition in a triangle, the sum of all three angles in is 180 degrees. Its negation would be in a triangle, the sum of the three angles is not 180 degrees.
Perfect. Oppo, what do you think about using negations in solving math problems?
I think negations help us cross-check and ensure the accuracy of a proposition. For example, when solving equations, if the negation doesn't hold, it might indicate an error in the solution process.
That's a very insightful point, Oppo. Well done, everyone. You are all doing great. Let's apply this concept in the practice problems. Today, we will work on some exercises to better understand the three concepts: propositions, proposition with variable, and negation of propositions. Let's start with the first exercise. Now look at on the board. Which of the following are propositions? If they are, determine whether they are true or false. A. 16 is not a prime number. B. The 7 divides evenly by 5. C. The equation x squared minus 4 equal to 0 has solution. Who can answer question A?
Miss Amber, statement A is a proposition. It is true because 16 is not a prime number.
Very good, Emerald. Now, how about question B? Sophia, can you try?
Question B is not a proposition because it is a question, not a statement.
That's correct, Sophia. Now, for question C, Lapis, what is your opinion?
Mrs. Amber, statement C is a proposition with variable because it only becomes true or false when we find a solution to the equation.
Exactly. Does the equation x squared minus 4 equal to 0 have the solution, Lapis?
Yes, it does. The solutions are x equal 2 and x equal minus 2. Therefore, the proposition is true.
Perfect, Lapis. Well done. Now, let's move on to the next exercise. I will write it on the board. Write the negation of the following propositions and determine their truth values. A. In triangle, the sum of the three angles is 180 degrees. B. 6 is not a prime number. Kianai, can you help me with part A?
Mrs. Amber, the proposition is, in a triangle, the sum of the three angles is 180 degrees. Its negation would be, in a triangle, the sum of the three angles is not 180 degrees. This negation is false because in any triangle, the sum of the three angles is always 180 degrees.
Very good, Kianai. Floret, can you handle part B?
Yes, Miss Amber. The original proposition is 6 is not a prime number. Its negation would be 6 is a prime number. This negation is false because 6 is not a prime number.
Excellent work, everyone.
Hey Emerald, hey Kianites. It is so great to finally catch up with you guys. I've always wanted to know more about your hometowns. Can you tell me about them? Sure, Opal. My hometown is Cần Thơ, in the Mekong Delta. It is known as the western capital of Vietnam. Have you ever been there? Not yet, but I've heard it's famous for its floating markets. Exactly. The Cái Răng floating markets is a must visit. You'll see boats filled with fresh fruits, vegetables, and other goods. It's a vibrant scene, especially in the early morning.
That's so amazing, Emerald. I have always wanted to experience the floating market. My hometown, Da Nang, is completely different though. It's more about beach and mountains.
Oh, Da Nang? Isn't that where My Khê Beach is? I've seen photos of it. The water looks so clear.
Oh yes, My Khê is stunning. We also have the Marble Mountains, which are filled with caves, pagodas, and amazing view. It is such a peaceful place. And don't forget Banana Hills with the Golden Bridge. Tourists love it there.
Whoa, Da Nang has a mix of nature and modern attractions. Cần Thơ is more rural with lush orchards and waterways. I think our cities really showcase Vietnam's diversity.
Today, we will dive into the concepts of the conditional propositions, converse propositions, and two important mathematical logic symbols, for on and is. Who can define the conditional propositions?
A conditional proposition is a statement of the form if P, then Q. It is only false when P is true but Q is false.
Correct, Floret. Can you give an example?
For example, if x equals 2, then x squared equals 4. This is a true conditional proposition because x equals 2 leads to x squared equals 4.
Very good. Kianai, can you give an example of a false conditional proposition?
Sure, for instance, if x equals 2, then x squared equals 5. This is false because x equals 2 does not lead to x squared equals 5.
Exactly. Remember, a conditional proposition is false only when P is true and Q is false. Now, let's move on to the converse propositions. Opal, can you define it for us?
A converse proposition of B to Q is Q to B. It doesn't necessarily to have the same truth value as the original proposition.
Very good. Very good, Opal. Safir, can you provide an example?
If the original proposition is if a number is divisible by 4, then it's even. its converse would be, if a number is even, then it's divisible by 4. The converse is not true because not all even numbers are divisible by 4.
Exactly, Sophia. Emerald, can you tell us when both the original proposition and its converse are true?
When both propositions are true, they are called equivalent propositions. For example, if a triangle is equilateral, then it has 3 equal angles. And if a triangle has 3 equal angles, then it is equilateral.
Excellent, Emerald. Now, let's move to mathematical symbols. I will write on the board. 4 on x belong to real number. X squared greater than or equal to 0. Is x belong to integer. X plus x equal to 0. Who can explain what the mathematical symbol for on means? Lapis, please explain.
Means for all. The first example means for all natural number x, their square is greater than or equal to 0. This proposition is true because every natural number satisfies the condition.
Very good. Now, what about the mathematical symbols exist? Very good. Florid, can you explain?
That symbol means there exists. The second example means there exists a natural number x, such as x plus x equals 0.
That's correct, Florid. This symbol is very powerful and widely used in mathematical logic. Remember, for symbol expresses generality, while its symbol emphasizes the existence. When solving problems, think carefully to determine whether the propositions are true or false. Now, let's try a quick exercise. I will write it on the board. Check the truth value and write the converse for the following statement. For on x belong to real number, x squared plus 1 greater than 0. Number 2, is x belong to natural number, x squared equal to 2. Safir, can you try the question 1?
For all x belong to real number, x squared plus 1 greater than 0. This proposition is true because for any real number, x squared is always non-negative. X squared plus 1 greater than 0.
Exactly. Now for question 2. Oppo, can you answer?
X is x in x squared equals 2. This proposition is false because no natural numbers squared equals 2.
Very good, Oppo. Everyone, make sure to practice the similar exercises at home. If you have any questions, I am here to help all of you. Okay, so that's it all for today. Thanks for enjoying our class and have a good day too.